All right, so let's do one more example. Now again, the point of today is looking at questions that are a little bit different from last night, right? Last night, all the problems had a y-intercept, they had x-intercepts, it was easily factorable, it was easy to find the vertex because it was in the middle of those x-intercepts, right? And so it was easy. These two questions that I'm doing today in the previous video and then in this one are going to be a little bit harder because it's going to be missing something. Right? The last one was not easily factorable. It made it a little bit more difficult. We had to find those x-intercepts. It made the x-intercepts a little bit more nasty. And so now in this one, we're going to see a situation that's even a little bit more different. So let's go ahead and look at example number 2. So as before, you can do this in any order. You can, like I say, you can do the vertex first. You can do the x-intercepts first. It doesn't really matter. As I said before, I kind of like doing the y-intercept first, just because I know that I'm going to get a y-intercept, x equals 0. The other thing I like to do first sometimes is the vertex, but since we're still kind of learning about that, then I won't be doing the vertex first today. But after today, most of the time I will probably do the vertex first, just because I like knowing where the middle of the graph is. So y equals 2, right? So I put in 0 for x. I solved y equals 2. You may be starting to recognize that the y-intercept is usually this last number right here. It is always that last number if it's in standard form. So I got y equals 2, so that's the point 0, 2. So I'll go to 0, 2. And now we'll go ahead. Let's try the x-intercepts. So let's change colors here. We'll go x-intercept. Now to get the x-intercept, we make y equal to 0. So we go 0 equals x squared plus x plus 2. Now, some of you will notice right off the bat that this is not easily factorable. In fact, it is not factorable into nice numbers. It would be rather nasty. And so let's go ahead and we'll go quadratic formula. So we're going to go x equals negative b plus or minus square root b squared minus 4ac all over 2a. So negative b is 1, right? Plus or minus square root b squared minus 4 times a times c. If you're having a hard time with the quadratic formula, you probably want to go look at one of the quadratic formula videos. But here we go. So that simplifies to negative 1 plus or minus 1 squared is 1. Negative 4 times 1 is negative 4 times 2 is negative 8. Oh, 1 minus 8 is negative 7. Now, we talked about this in class, at least for 2 of the classes. What does it mean if you have the square root of a negative number? It means there are no real solutions. Okay? Wonderful. But what does that mean with respect to the x-intercept? Because we're supposed to be finding the x-intercept here. If I get no real solutions, what does that mean about the x-intercepts? There are no x-intercepts because there aren't real solutions. Okay? So there aren't any x-intercepts. So using our excellent knowledge of quadratics, we now know that it must go something like this where it scoops down and then back up, or here where it scoops down and back up, but it doesn't ever get to the x-axis. That would be a situation where you don't have x-intercepts. Okay, so what else can we do? Well, we learned in the previous video how to find the vertex without needing a set of points. So we can actually find the vertex. We can get the x value of the vertex, which is negative b over 2a. Okay, even if the quadratic formula doesn't work, this will, because this just gives us the center line. It doesn't give us anything else. So negative b, which was 1, over 2 times a, which was also 1. So that gives me negative 1/2, which is negative 0.5. Okay, so that gives me the x value of the vertex. It's also the axis of symmetry, so I can draw that in right here. Ooh, that's not nice. Okay, there's my axis of symmetry. Right, now it's dashed because that's not really part of the graph, right? It's just a helpful piece. And so x equals negative 0.5 is the equation of that line. So now some of you recognize that, yes, we could reflect this point across right now. Absolutely, you could do that. I'm going to do that later. I still want to finish the vertex. So I got the x value of the vertex. How do I get the y value of the vertex? Well, we take the x value, we put it into the dang equation. So y equals negative 0.5 squared plus negative 0.5 plus 2. So here we go. 0.5 times 0.5. Oops, I did minus. Sorry. So 0.5 times 0.5. And then we're going to go plus negative 0.5 and then plus 2. So we get 1.75. And so that's my vertex. Negative 5, positive 1.75, which is right here. So negative 0.5, comma 1.75, right there. No, it's not perfect, but that's the vertex. So that's the lowest point, which means it's got to start going back up. We already mentioned that we can reflect this across. That's half a space away, so I expect half a space away to be the other point. So there we go. So that will be negative 1, comma 2. We've reflected across. But I've only got 3 points. We know we're supposed to have 5 points. And so I'm going to need another couple of points. So in order to do that, the easiest way to do that is just to use a table, plug it in, put an x in, get a y out. And so I'm just going to choose, what the heck, you can choose 1. 1 seems like a good, nice number. 1 is usually easy because then I can go y equals 1 squared plus 1 plus 2. That would be 1 plus 1 plus 2, which is 4. So 1 comma 4, 1 comma 4. From that point, if you want to put another number, you can. Or you can recognize that this is 1.5 spaces away. So let's go 1.5 spaces away. So I've got 1 comma 4, and I've got negative 2 comma 4. And so I've got enough points now. That's good enough to give me a nice curve. Please do make sure it's curved. It's a U, it's not a V, it's a parabola. All right, so there you go. We've graphed the second one. Hopefully this is enough to get you on your homework.